Hello class, welcome back. Today I'm going to do a short demonstration for you to try to address some of the concepts that we were brainstorming and drawing models based on our observations from last week. So I left you off last week with a question: is sound a form of energy? And then you guys drew what you saw on that website, where the air molecules were moving back and forth after a disturbance, after an object was struck and created sound. So because we know that the definition of energy is anything that can cause change, therefore, when an object produces sound, it is being struck, it is being disturbed, it is vibrating and causing air molecules near it to move. So yes, sound is a form of energy. We might have referred to it in our last unit as dissipated energy, energy that cannot be brought back into that system of gravitational potential energy and kinetic energy. So yes, sound is a form of energy. Now, some of the variations of sound that you played with last week in your sound stations, there's one key point I'd like to address here, and that is manipulating sound to make different types of noises. We used a ruler, hopefully you had one at home. A rubber band or a guitar string would do the exact same thing. And we noticed that if we have a lot of the ruler hanging off the edge of a desk, there's more to vibrate, and the vibrations are kind of slower, making this deeper noise, a low noise. But if we bring it in where the vibrations are faster, when you get faster vibrations, that changes the type of noise that you'll hear. So the speed of the vibrations, known as frequency, determines what type of a pitch or what type of a sound, either a low or a high. And of course, how hard you strike it, that will also affect how loud the sound is. I'm going to try to give us a visual here of waves using a slinky. So I'm pretty sure we're all familiar with what a slinky is a single coil of metal, but it moves, it's elastic. And so I'd like you to pay attention. One type of wave that I'm going to show here, the wave that you drew in your model, like an ocean wave, may have had this sort of a shape to it. A rounded top and a rounded bottom. And I'd like you to pay attention right now that my hand is moving up and down. That is the direction of the disturbance. My hand is moving up and down, but the wave is moving outward. So my hand is moving up and down perpendicular to the direction of the wave. And just like I said, if you do a higher frequency, more of them, you'll get, sometimes it takes a minute, but you get a wave that might look more like this. There we go. That would be a higher frequency. Now, as I mentioned as well, if you have a greater disturbance, if my hand is putting more force into it, you get a taller wave. That the height of the wave is called the amplitude, and it determines how strong that wave is. Okay, I'm gonna let this slow down. Now, this type of a wave is what comes into our minds most often. However, this is not the type of wave that sound wave is. Sound wave is called a compression wave or a longitudinal wave. And that's because when an object is struck and is vibrating, it's not vibrating this way, sending sound out. It vibrates in the same direction that the energy travels. So this might be a little more subtle, but you can see, you start to see little changes in the springs going in and out. And that has to do with areas of higher concentration or density of coils here, much like the air molecules in the visual you drew. This might be a little bit of a better visual if I pull back and let go. You can see that area where it's compressed moving back and forth. I'll do a couple more. So, finally, coming back to our warm-up from last week, what is a wave? A wave is a transfer of energy caused by a disturbance. So it is a way that energy moves from one place to another. Sound requires a disturbance, causes an object to vibrate. That vibration pushes air molecules in and out of areas of high and low concentration, and it does so in a pattern where the energy radiates outward. It's a lot of information to take in. So the remainder of today's lesson is going to be some reading to help anchor this information that I'm also posting, followed by 6 questions at the end. This assignment, while I recommend that you do it before tomorrow's lesson, which will be a little bit of a shorter lesson since this might take a little bit longer, I would recommend that you do this first, but it won't be due until the end of the week when we post everything in our notebooks from last week and this week. Okay, I hope everybody's doing well. See you later.